This is a limited demonstration of Hall effect apparatus. There are two parts to this experiment. One, calibration of electromagnet. Two, response of N-type and P-type semiconductors and determining its Hall voltage, carrier concentration, carrier velocity and Hall coefficient. Part 1, calibration of electromagnet. There are three parts to this setup. Number 1, electromagnet. This electromagnet is capable of producing a magnetic field up to 5 kilo Gauss. Number 2, constant current power supply. This power supply has a fixed voltage and the current can be varied up to 4 ampere. Number 3, the Gauss meter. This Gauss meter can read a magnetic field up to 20 kilo Gauss. This is the Gauss probe. This Gauss probe has a sensitive Hall sensor. Carefully slide the probe outwards like this. The sensor will be visible. Gently fix the probe in the holder and align to the center of the magnet. Connect the Gauss probe to the meter. Connect the power supply to the magnet. Align the Gauss probe such that it is to the center of the two poles of the magnet. Make sure you align it horizontally and vertically. In the constant current power supply, vary the current gradually in steps of 0.1 or 0.2 ampere. You may use both fine and coarse knob to do this. Once you set a current value, wait for at least 15 seconds before taking the reading of the magnetic field. This is because the Gauss meter takes an average of 20 values and displays it on the meter. Also, the magnetic field itself builds up gradually when the current increases. Similarly, increase the current in steps of 0.1 or 0.2 ampere up to 4 ampere, and in each case note down the magnetic flux value in the Gauss meter after 30 seconds in each case or 15 seconds. You can see that magnetic flux is approximately 5.1 kilo Gauss for a current of 4 ampere. Tabulate current versus magnetic flux. And plot a graph. From the graph, calculate slope that gives the value of magnetic sensitivity. Part 2. In this part, we will check the response of N-type semiconductor. In our regular setup, we provide either N-type or P-type crystal. connect the 4 terminals of the N-type semiconductor in the circuit provided. Make sure to connect the A, B, C, D terminals in the right order. Now connect the milliammeter and voltmeter using patch cords. Now connect the constant current power supply to the electromagnet. Now insert the sample in the stand and align the center of the semiconductor sample to the center of the magnet poles. Be sure to align it vertically and horizontally. Now switch on the setup and set the hall current to 2 milliampere. Now note down the corresponding voltage. In this case it is minus 38.1 millivolt. Switch on the electromagnet power supply, making sure both the knobs are at 0. Next, increase the electromagnet power supply current in steps of 0.2 ampere. You may use the coarse and fine knobs for more accurate adjustment. Now note down the corresponding voltage after waiting at least 15 seconds. Now increase the electromagnet current to 0.4 amperes and note down the corresponding voltage. Similarly, increase the power supply current up to 3.6 ampere and note down the corresponding voltage in each case after waiting at least 15 seconds before taking the next reading. If you have purchased a p-type semiconductor sample, now replace the n-type sample with the p-type sample and repeat the above steps. Refer our user manual for detailed explanation and steps involved to calculate Hall voltage, carrier concentration, carrier velocity and Hall coefficient.